Hello guys, and welcome to my YouTube channel. In this video, I am going to show you how to convert almost any supported LCSC C component into a KiCad library using one terminal command. The process starts with an LCSC part number, such as C39828. The EasyEDA2 KiCad tool retrieves the available EasyEDA data and converts it into a KiCad schematic symbol, PCB footprint, and 3D model. Everything can be executed from Windows Terminal, PowerShell, or command prompt, so the KiCad terminal is not required. By the end, you will know how to install the converter, run the command, locate the generated files, and add them correctly to a KiCad project. First, open the required component page on the LCSC website. Every component has a unique LCSC part number beginning with the letter C. Do not confuse this with the manufacturer part number. In this example, the manufacturer part number is BC817-25215, while the required LCSC code is C39828. This C number is the value that must be passed to the conversion command. Copy it exactly, including the capital letter C. Also confirm the manufacturer, package, and electrical specifications before continuing. Selecting the wrong C number may generate a completely different symbol or footprint, even when the component names appear similar. Before converting any component, install the EasyEDA2 KiCad Python package. Open Windows Terminal, PowerShell, or command prompt and execute py-mpip install dash upgrade EasyEDA2 KiCad. The upgrade option installs the latest available version or updates an existing installation. Python must already be installed and accessible from the terminal. You can test this by running py ---- version. This installation only needs to be completed once. Afterward, the same converter can be used for different resistors, sensors, transistors, connectors, integrated circuits, and other supported LCSC components without repeating the installation process. The main conversion command is py-m EasyEDA2 KiCad --full --LCSC _ID equals C39828. The py-m section runs EasyEDA2 KiCad as a Python module. The full option requests every available library element, including the schematic symbol, PCB footprint, and 3D model. The LCSC _ID option identifies the exact component that must be downloaded. For another component, only replace C39828 with its own LCSC C-number. Keep all other parts of the command unchanged. After pressing enter, the tool connects to the available EasyEDA component data, converts it, and writes the KiCad compatible library files to the output directory. Here is a real conversion example using the Nexperia BC817-25215 NPN transistor. The component uses an SOT23 package, and its LCSC part number is C39828. After confirming these details on the component page, run the full conversion command with C39828 as the identifier. The converter processes the available symbol, footprint, and 3D model data and creates the KiCad library structure automatically. This same workflow applies to other supported components. Copy the correct C number, replace the example identifier in the command, and run it again. Always compare the generated pin numbering and package orientation with the official manufacturer datasheet before using the part in a PCB design. The conversion creates three important library items. The file ending in .kicad_sim contains the schematic symbol. The folder ending in .pretty is the KiCad footprint library and contains the PCB LAN pattern. The folder ending in .3D shapes stores available step and WRL models for three-dimensional PCB viewing. These three items work together to create a complete component. The symbol represents the part in the schematic, the footprint defines the copper pads and physical placement, and the 3D model shows its mechanical appearance. Some components may not include a usable 3D model, so always inspect the generated output before relying on it. By default, EasyEDA2 KiCad normally creates its library inside the user documents folder under KiCad and EasyEDA2 KiCad. This location contains the symbol file, footprint folder, and 3D model folder. You can also select a custom project location by adding the output option to the command. For example, an output path such as /libraries, /LCSC, keeps the generated library inside the current project. A project local library is easier to archive, share and move between computers. Keep the symbol, footprint, and 3D model folders together, because the footprint may reference the model through its relative file path. After generating the files, they must be registered in KiCad. For the symbol, open Preferences, then Manage Symbol Libraries. Select the project-specific table and add the EasyEda to KiCad.KiCad_sim file. For the footprint, open Preferences, then Manage Footprint Libraries and add the EasyEda to KiCad.Pretty folder. Once both libraries are registered, the imported component becomes searchable inside the schematic and footprint selection tools. The footprint normally contains a reference to the model inside the 3D Shapes folder. Preserve the original folder structure so this link remains valid. Then place the symbol, assign its footprint, and inspect the result in the 3D viewer. The converter also provides options for more specific workflows. Several LCSC identifiers can be supplied when multiple components must be imported into the same library. The overwrite option can replace an existing converted component when updating its data. The symbol option downloads only the schematic symbol, while the footprint option generates only the PCB footprint. These variations reduce unnecessary files when the complete package is not required. However, the full option is usually the easiest choice for a new component, because it attempts to create the complete symbol, footprint, and 3D model set. Use override carefully, especially when you have manually corrected an existing library item, because those modifications may be replaced. Several common issues can prevent the conversion from working correctly. When the terminal reports that PI is not found, try using Python instead, or reinstall Python with the Add Python to Path option enabled. When the wrong component is downloaded, return to the LCSC page and verify the exact C number. If no library files appear, confirm that the full option was included and check the terminal for connection or permission errors. When KiCad cannot find the component, register both the symbol file and footprint folder in the library managers. Most importantly, never assume that automatically converted data is perfect. Verify the pinout, pad numbering, package dimensions, orientation, and 3D model against the official datasheet. Thanks for watching this video, guys. Please share, like, and comment below. Also subscribe to my YouTube channel for more videos.